All right. So I am a principal software developer at SAS Institute. And I might be responsible for some of the supply chain pipelines that we built, but I have been using plausible deniability to escape that type of blame. Currently, I'm a security lead for R&D. For a little background, SAS is a 40-year-old analytics, artificial intelligence, and data management company. We're an ISV. We still deliver software to customers. We deliver RPMs, Debians, OCI containers on several architectures. We've got a pipeline that builds, tests, stores, and eventually allows us to deliver all this stuff to the customers. So we're a little different. I would love to go work at a software as a service in my next life, but for now, I've got lots of packages to worry about. So I'm going to talk about supply chain, robots, electric sheep, and SLSA. Originally, this talk was pretty SLSA heavy. Version 0.1 of SLSA was really strict and really complete. And SLSA for version 1.0, they have backed off and focused on the build section. So what I'm going to do is I'm going to talk about the Executive Order 14028 and the SSDF standards, and then we're going to throw some ISO in here and some SLSA, but we're not going to talk about that really long because you guys can go read about that. And what you really want to do is you want to get to some of the crazy ideas I have. A couple of things you need to know about the executive order, like some points that they definitely lean on is that they want you to separate and protect each environment. They want you to secure hardened endpoints, improved executable security. So use compilers that do the right thing. They want least privileged access to the code and tools, provenance data and SBOMs, and they want software release integrity. So how does SLSA fit in? SLSA is a checklist of standards and controls that we use to prevent tampering, improve integrity, secure packages, and infrastructure in your projects and enterprises. It's how we get from safe enough to being as resilient as possible at any link in the chain. The framework establishes 3 trust boundaries, the right standards, attestation, and technical controls, so we can harden the systems from threats and risks. This is a cool slide. It pretty much does what you said. It does what it says. One thing I want to bring up is that I'll focus a little bit later on validating artifact integrity, and that's like a key component of SLSA, especially in the build section now. And so we'll get to that. Let's see. So each level works to achieve a greater sense of security based on the previous level, right? So maybe some of us are at 0.1, and that's good luck. It's the wild, wild west, right? We don't know what's going on. In level 2, provenance exists. And there's provenance showing how the package was built, and there's documentation that helps us not make mistakes while we're building these packages. At level 2, we've got signed provenance generated by the hosted build platform, and then this prevents tampering after the build, right? So I build my package, I sign it, and then I can validate that that package is what it says it is based on the signature. For level 3, we've hardened the build platform. No devs are allowed in there. Nobody's allowed in there. There's one door in, one door out. And this helps prevent tampering during the build. And then, of course, we've built on the other layers, right? So we end up with hermetic builds, which is where we all want to be. So I have some ideas around some of these things that we want to achieve. And I'm going to go about it in an interesting way. I think you guys will appreciate it. The real answer here is that you pay for a supply chain platform and let somebody else worry about this, and you sleep at night. But some of us aren't that lucky. Some of us have a long in the tooth, organic, hybrid cloud solution of in-house solutions cobbled together with duct tape and baling wire. So And the older that pipeline gets, the more fun it is to work on. So I'm going to present a series of what ifs, right? Let's start with something that should be obvious, but not everybody takes it as seriously as I do. And that is, what if we use GitOps for everything? Okay. I'm talking documentation. I'm talking your code. I'm talking infrastructure as code. I'm talking your policy, your ADRs. All of it is in Git. And I know you're going, well, that's kind of crazy. Why are you putting all that in Git? Well, so take documentation. Say I want to require 2 reviews on a pull request in order for it to be merged into main. Well, then I'm guaranteed that I've had 2 reviewers of the documentation change, and I know who the 2 reviewers were by the Git history, and I know who the original author was because of the Git history, and they can't get it in until we go through through our CI, right? And so now I've got CI running against my documentation. I've got 2 reviewers, and I've got a Git blame trail to tell me who did the change and why we made the change. And then at the end, after it's merged, I run even more CI that does the publication from Git to wherever we want the documentation to end up in. For us, it's Confluence. And so we wrote a tool in Python that does markdown to Confluence. The infrastructure as code, that's pretty much straightforward. You guys all know that answer. You've got Argo CD hooked up to a repo, and then you get the same 2 reviewers that I have before you can make changes that are automated in deployments. Policy and ADR, those are 2 things where that Git log trail, that audit trail really helps you out in the long run. So those are the reasons why we use GitOps. Moving on, this is the best part. So what if we had a complete inventory of our CI/CD infrastructure? That would be awesome, wouldn't it? Seems pretty necessary. In our world, the DevOps teams get to do their own deployments. Seems safe, right? Compliance and security problem 101. I didn't deploy it, so I don't know where it is. So how can I enforce it? Well, we've got the old school way. I've got hundreds of Jenkins servers. I got a Confluence page over here that's got a list of all the URLs of the Jenkins servers. And so we know where all the Jenkins servers are based on this list, except for the ones that the developers deployed with Shadow IT to get around the restrictions we put on the Jenkins servers we have. Okay, so that didn't help that much. So the next problem we ran into is that we built an event-driven framework for our pipeline. Its services and our events are all asynchronous. And we're not sure what service gets triggered by what event because the development teams can deploy their own services on top of the infrastructure we've deployed. So how do we fix this? What are some ideas I can give you guys around this sprawl that I have caused? And, it was my fault, that's what happens. You're doing stuff, you break things, you lose things. I don't know where that server is. Anyway, we built what if we build out a framework so the DevOps teams get inventory management for free? What if we automate the IAC audits, which would tell us where things are deployed? That's not too bad an idea. I mean, as long as they checked it into a Git repo, based on my GitOps theory, then we would know that the manifests would tell us where these things are. That doesn't help if they didn't use GitOps. So what if we had event-driven registration? Basically self-registering services. The idea is that I've got this service. It's running on the events in the event framework, and then there's a Kafka topic, and the service ARPs itself when it starts up and says, "Hey, I'm here." It goes on the Kafka bus. You've got a service over here that's collecting up all these ARPs off of the Kafka bus and cataloging where all the things are. That's a pretty decent idea, right? That's great, right? Until you find out that you're 2 abstraction layers up and the IP addresses you have in the Kubernetes cluster are only related to the Kubernetes cluster. All right, so now I've put myself in that situation. How do I solve that? What we could do is there's this thing called download API. right? And then for Kubernetes, this means exposing the pod information to the containers through environment variables, right? So in the manifest, there's a couple of environment variables, and they surface up lower level Kubernetes information. It tells us which cluster it's running on and where that cluster might be. And then we get farther down the chain. And I know what you're thinking. You're like, well, if the developers are doing the deployments, how do you get them to add in this downward API? Well, the trick is that you put it in the example manifest and you don't mark it as something that they need to change. And I guarantee you the developers will deliver it or deploy it just as it is, and you'll get your downward API. So yeah, it is what it is. All right. So the next thought I had is that what if we remove out of band human checks, right? Every time I come around as a security lead and implement a bunch of security, developers get it, bogged down. It makes them harder to get their job done, and we made their job more complex. So what if we shift everything as far left as we can, right? And then automate everything else to the right. And this keeps the dev experience where I want it, which is git, pull, hack, git, push, create, review, right? Get two people to review it, and the PR passes all the CI checks and it merges. The CI checks, of course, are over on the right, or kind of hang on. The CI checks are right here in the quality and the scan, and right in before the source code gets merged. But so if we get to that point, the devs don't care what happens after they've fixed everything in the pull request. And then we have, how do you handle vulnerabilities in that case? So, we had some vulnerabilities, we fixed them. So we're running Sneak, plug for Sneak. We're running Sneak, and we have IDE plugins so the developers can see all of their stuff in their IDE. We also have integration into the GitHub pull requests. And so the GitHub pull requests won't pass until we've remediated whatever issues we've run into. So the developers go and they fix all these things, and then they, remediate, and then there's a time box on the remediation, and then the automation on the right swings back around every time and says, okay, your time frame to fix this remediation is up. You either need to get another exception or I'm going to break the build. I need a clicker. Wait, go back. Click too far. So as we shift left, we get the problems earlier in the STL lifecycle. Scanning and code quality are remediated in the IDE. Code merge is blocked until the quality of security standards are met. Keeps your dev in the IDEs. They're not off in the web browser, back in the IDE. Brian's talk before this made me think about that, how he could get so much done and never leave his IDE. And then after the merge, the robots are the ones doing the due diligence and producing your audit trail. It keeps the developers working on the code, and the robots keep the compliance and security as best they can. And then we automate provenance on the right side in the pipeline, so it can't be falsified or tampered with. Okay, all this shift left, this compliance is great, but we still have attack vectors. If this doesn't keep you up at night, it should. And compliance doesn't equal security. So just because we're compliant doesn't mean we don't have these attack vectors. It just means that we have compliance. Compliance can help, but closing the attack vectors should be priority number one. Monitoring. Monitoring is great. We should do that. However, verification of environment, materials, process, and artifacts before running the actions increases security. And look, I'm not telling you not to monitor. Monitoring, auditing is a big part of the EO 14028 focus, but closing attack vectors should be priority number one. Okay. Attestations. You've been hearing me talk about provenance. Provenance and attestations, we kind of interchange them a little bit. It's the same. It's kind of all along the same idea, right? So what if we make SBOMs? SBOMs are good. We should do that. In the end, SBOM is just a list of ingredients. At some point in the supply chain, we must be able to vouch for ourselves, right? So we have to create an attestation. The way to create an attestation that is non-falsifiable is to cryptographically sign it to verify your assets. And then we automate the provenance so that it can't be falsified again. Let me give you an example of what an attestation would look like. This is a real world example, not a YAML example. So you're going to get lab work done with your doctor, right? And then you've got the environment. And the environment is what lab is the test taking place in and on what date. The process is what machine is performing the test and what are the configuration details of that test. The materials are whose blood is going into the test. This is very important. Is the chain of custody verified? And the artifact is the output of the test the output of the test is the test results. The blood test results should be verifiable and traceable. So what if we teach the robots to verify the environment, the materials, the process, and the artifacts before running the actions? By verifying everything, we've already said we're going to increase security. And verification tools validate the signed provenance and verify metadata, including verifications of the source repository used to build the binary. That is a lot of verification. But verification allows us to answer an important question. Is that an electric sheep or is it a wolf? Rachel was replicant. How did Deckard miss that? All right. So in the end, we want to build some automation to tend to our electric sheep. And then what does that look like? So the robot gets the signed provenance and validates the signature of the provenance. And then he uses the SHA sums from the provenance to validate what it's about to execute. Like if the rules for this particular build are make install, then I want to make sure that I'm running make and make install and not make install, make foo, right? And then it uses the same, a different piece of provenance to validate that the tools are what they say they are, right? If I'm using version 1.0.0 of tool foo, I want to make sure that I didn't get 2.0.0 of tool foo. It validates that the instructions are what they're supposed to be. So depending on what type of build scripts you're using, it goes through and says, okay, you're going to run this step, and this step. And then we SHA all that and it gets put in the provenance. And then when you go to run it, you pull the provenance and go, okay, I'm running this step, this step, this step. Is that what we're doing here? And then in the end, it validates the resulting artifact. It creates signed provenance for it. So now you've got this artifact that you've got signed provenance for, so that when you go and download that artifact to go use it somewhere else, you can grab its signature and go and know that it's what it's supposed to be and it was built in a process that you trust. So the next trick is that you use the pipeline to build the pipeline. So in the past, we might have been very worried about the product we were delivering to the customer and not as worried about the pipeline that builds the product that delivers to the customer. But now we're very worried about that. So you use the supply chain to secure the supply chain, and none of your infrastructure should be built anywhere other than this one pipeline. Now, there's another thing I want to get into, but it's probably a presentation for another time, and that's deterministic builds using two different pipelines. The idea is that I've got pipeline A and pipeline B, and they are different mechanisms, and we build the same source code through them, and at the end, we test the binaries, and if they're identical, then we are fine, and nobody's tampered with anything. Let's see. So zero trust, it's coming. And securing your supply chain is not just scanning the code in compliance, it is implementing zero trust. And you want to follow the principle of never trust, always verify. And the verification steps we talked about are also required for zero trust. I got to do that really fast. Melissa, you want to pop back in? Because I'm Smitty, and I'm afraid of robots.
I was going to ask you about that.
We're getting to it, right?
Yeah. And I think we might as well just jump into that because I think you have a good story about this. Yeah. So why are you afraid of robots, Brett?
You run amok. Do you know how easy it is to get a robot to run amok? So we're building out this event-driven pipeline, right? And it's early, and we've got the R section, the infrastructure of it, kind of figured out and built out. And the idea is that you post a receipt to the service, and then the service creates an event, and then everything downstream is listening to that event. It uses the data that you posted for the receipt to go do stuff. So we had an early adopter, and we told them that they were going to build this thing to watch for these events, and then it should do something, and then post receipts, so that it could, on what it did, right? And this particular thing was a security thing. Well, we were early and we didn't think about guardrails. So this thing managed to fork bomb itself into a 97 megabyte receipt. So it was posting a receipt. The service was creating an event, and it was listening for the same event and firing itself again.
Oh,
right.
No.
And then the original message was like, a couple hundred kilobyte, and it made it to 97 megabyte before it kicked over and died. This led to us putting in a 1 megabyte limit because Kafka at the time had a 1 megabyte limit. So we put a 1 megabyte limit on the service, and we went and wrote a bunch of code into our base library that made sure that you weren't allowed to listen to the event you were creating. So that one was pretty awesome. Yeah, and it happened more than once, which that's how it goes.
Yeah.
Security.
So easy. Go ahead. So easy
for
that to happen.
We were doing something that didn't have a lot of. This was 4 years ago, so there wasn't like you couldn't Google on the internet about what we were up to.
Right.
Kafka was mainly a streaming service, and we were kind of cheating and using it as a message bus. So it was interesting.
Yeah.
What was the other story I'm supposed to tell you?
That was the main one.
Right.
Yeah. But I did have a couple of other questions for you, though. Why all this push for GitOps?
Why all the push for GitOps? Oh,
yes.
That was the main one. Why all the push for GitOps? Because here's an example. In a previous team, and they did all of their ADRs, right? We know what ADRs are, right? They're architectural decision records. And these are like a point in time. I said, Melissa, you and I are going to put together this event-driven system, and it's going to look like this. And so you're like, well, we need to make sure we talk to the Kafka bus this way. And we're going to go, okay, I'm with you, right? The messages have to look this way. We go write an ADR, and me, you, and everyone else in agreement is on the top of the ADR. And then we commit it to the Git repo. Well, in my case, I commit the Git repo, but we say, okay, this is the ADR. So on October 31st, we made this horribly stupid decision. Next year, we come around and we're like, my God, who made that decision, right? And then it's like, we go back to the ADR and we go, oh, it was Melissa and Brett. Well, figures, right?
Of course.
They don't make good decisions anyway. So if you check that into Git, so anyway, we put that in Confluence, okay? We forget to lock it down. Anyone could come along and hack it, right? Change it. We could accidentally delete a section of it and push update right afterwards. And yes, Confluence has a fallback and all that other stuff. But 2 weeks from now, our powers that be are going to swing in and say, we're not paying for Confluence anymore. You're going back to Wikipedia.
Right.
And so now you've got this document only in Confluence, in a Confluence markdown, right, that you've got to go convert over to Saspedia. Now, say you got hundreds of those documents or thousands like I do, right? If they're in Git, I've got the blame trail, and all I have to do is write something to translate them from whatever language I decided to write them in. And look, I'm old school. I know a lot about old style doc stuff. We can talk latex if we want to, but we did Markdown because it renders really well in GitHub, right? And so now you've got a renderer for your documentation. You've got an approval system. You've got a Git history of what's been changed in your documentation and when. And if I wanted to move from GitHub to GitLab, it's easy, right? And so that's pretty much the reasoning behind the documentation. I mean, the IAC explains itself. Infrastructure and code. What day did I deploy this, and what day did the manifest change, and who's the knucklehead who put this Docker container in that manifest? Get blame, Smitty. I did it. I didn't. The robots did it. This goes back to why I'm afraid of robots. See, I didn't make that change to the manifest. We built a new image. The event system caught that build receipt, went and updated the manifest, updated it, pushed it. Argo CD caught it and deployed it. I knew I was supposed to put tests in there before I did that.
Right.
So the idea here is that you can hurt yourself with GitOps if you let the robots do the work, because when you do get blame, it's like robot 1, robot 2, robot 3. You need unique identifiers for the robots, and you need to be careful with mixing Git. How do I always put it? I don't like repos run by humans. I don't like robots checking in stuff to repos run by humans. You keep the robot repo and the human repo separate. And then so I could go back to the human repo and go, oh, this is why we changed how the part of this part of the deployment. And then the other one is, oh, well, this robot went and just deployed that because we built it. We just need to go build it again and fix whatever was broken, and it goes out again. It's a real CI/CD, right? It's like, oh, well, just go build it again, and then or fix the bug and build it again. But Git ties back into all that, right? Because it's your audit trail and it's your free audit trail. Mm-hmm. So that's pretty much why everything should be GitOps.
You have a lot of experience. One thing I appreciate about you, getting to know you, is just you've had a lot of trial and error. You've had a lot of quite a journey, getting all of this stuff in order, making it more secure, making sure, your ops is getting along with your devs too. And that was one thing I wanted to touch on. But before we get to that, I do want to ask you about SLSA, because you brought up SLSA at the beginning of your talk, and you were talking about the different versions. And we've had discussions about this, and I just want to know your feelings. I think this is a good venue for it. There were changes between .1 and 1.0. Tell us what changed and how you feel about it.
So when the SLSA spec came out, I'm going to tell you, I got AI camera that follows my head. It's pretty cool. So when I wobble, we're talking, it follows me. Anyway, so when the SLSA spec dropped, I was like, oh, this is the answer. Because version 1.1 covered almost everything that the executive order covered. And it was like a guidelines for it, right? You had the source section, you had the build section, you had the provenance section. I mean, it had all the sections. And it took care of everything you needed to do. And if you got to SLSA level 4, you were pretty sure you had done everything you could do to lock down your pipeline. I'm not going to lie, it was daunting. I looked at it and I was like, well, where are we? And I could squint and get us to SLSA level 1. And then there was 4 levels at that time. And I was like, okay, we're going to shoot for SLSA level 4. We're going to go put a plan together, and we're going to lock down everything. We're going to have, hermetic builds, signed provenance. We're going to have the source code's going to be locked down. We're going to have 2-person reviews on every piece of code. We're going to make sure that the owner of the code also does a review of any pull request. He could be one of the 2, or she could be one of the 2, or they. Could be one of the two. Somebody's one of the two. As long as it's not a robot. You don't want robots checking your code, because we saw what happened to Brian, right? I mean,
Right.
just saying. So it was a beautiful thing, and I went and wrote up all this stuff on it, made these presentations. We started working on it, and I think what happened, and so Google was the original drop the spec. And I've talked to some people from Google that know, and they're like, yeah, no, our internal rules make Salsa look trivial. I mean, they're way, way more strict about everything. And I think what happened is as the community started to take over and Google started to draw back a little bit, the community's like, we'll never get this done.
Right.
And so they took the part that's probably I'm torn between the source code and the build section, but I think the build section is the most important section of the Salsa doc. A lot of the rest of it is sysadmin 101. And they focused in on that, and they dropped the source piece and they dropped the other pieces. So it's pretty much just the build environment. And then they dropped down the levels to only having 3 levels. I still think level 3 is close to what we were calling for level 4, but they still dropped back on some of the requirements. And I don't know exactly. I really need to go track somebody down that's in that, in that space and ask them what they think happened. But yeah, that's how I think it went. But so that's why my talk ended up, I had to go pull from ISO 27001 for source code rules, right?
Right.
In ISO 27001, there's in the 27002 guidelines, they go through and tell you what you should do to lock down your source code on a least privileged, basis, need to know, and walk through that. And it lined up pretty well with the Salsa spec as best it could. So I had to improvise there. So hopefully they get back to it. I mean, it says to be TBD on all those things. So I'm assuming the community will come back and improve on it and get back to it. You and I should go figure out how we can go contribute to it, because
I think getting more input from the community is also helpful for sure, and especially from someone like you who's been in the middle of it and trying to implement all of these things. And I know that's an overwhelming process starting from zero. So just having, something like some goals that are outlined to get to is good. And I'm very sad that us as human beings, we have to feel pain before we make changes. And unfortunately, it feels like in a lot of cases, there's a lot of security measures that most of us are deficient in, that we are only now looking at and trying to improve.
So when I was at All Things Open, you were there. I saw a talk on AI to learn Python, and it was a wonderful talk. And the thing that the presenter mentioned the most is that you need to feel some of the struggle, right? So that the accomplishment feels good. So it shouldn't be so easy, but I would sleep better at night if it was just easy. I mean,
can you pinpoint the most difficult part for you and everything that you've done so far? What was the most difficult piece? And something I was alluding to earlier, did you have any problems with getting folks on board with this, with the changes that you wanted to make?
How long you been in this industry?
I think I already know the answer.
Yeah. You remember all those attack vectors I showed on that slide? Yeah. those are multiplied when you have developers. And so my famous saying is, if you have developers, you have attack vectors. It's hard. This is why we work so hard on the shift left, right? And this is why. So, like, if you take how Brian was working, where he just never had to leave the IDE and he could stay focused. The problem is it's not like that when you first start out, and the developers are already trying to get feature A and feature B out, and then you can run and tell them that the piece you released 2 months ago has 5 CVEs, go update it. And as they start to update it, it breaks the code, and they have to go mess with the code, right? And then so they lose time to this CVE on something they thought was already done. That makes them not want to do this. So fixing this stuff, so that's been the hard part, is getting developers on board with them understanding that security is their problem as well as mine, right? And then I should not use the word problem. Security is everyone's responsibility as a company, because like I like revenue. I know you like revenue. I like my bonus, right? And so if the more secure we are, the better chance we have of getting our bonuses, because it's just that one thing that's going to get us, nicked up, and it's bad for the company. It's bad for the reputation, and it could be bad, really bad for the customer. And my customers are government agencies and banks, so we don't really want that to happen with our customers. Anyway, so getting that message across has taken a lot of work, but making it easier to adopt makes it easier to get it going, right? We automated a lot of our security checks. On the right side, we will run the scan automatically after the build, and then we will create JIRA issues automatically if we have things that need to be addressed. And then we sort out things like the base image. If the base image has vulnerabilities in it, we create JIRA issues, and they get assigned to the guy who owns the person who owns the base image, not all the developers. And so that was pretty interesting, because we didn't do that at first, and we made a mess. And not being careful with who we assigned things to was really, really heavy. We're on the better side of that.
Yeah.
Now. The torch mobs are down. The pitchforks have been pushed down. So we're better from that.
You're all on the same team again, all trying to do the right thing.
No, but they're not trying to chase us down the hill anymore or burn the castle.
At least.
So, yeah. We're all developers.
Yes.